Find the term independent of x in the expansion of 2x plus 1 over x squared to power 12. So again, the term independent of x is basically the term in x to power 0. So it's a specific term, which means we need to start by writing the binomial theorem. So a plus b to power n is equals to whatever comes first plus n choose r, a to power n minus r, b to power r, plus whatever comes next. So by inspection, we can see that a is equal to 2x, b is equals to 1 over x squared, and of course n is equals to 12. And if we plug this into our general term formula, we can find the general term in this expansion, and the general term in this expansion will be given by 12r, because you're yet to find r, a, which is 2x to power 12 minus r, multiplied by 1 over x squared to power r. So we need to find the term in x to power 0. Okay? We need to find the term in x to power 0. What does that mean? It means that the combined powers of x will be 0. So the combined powers of x will be 0. So in that case, what we need to do here is we just need to combine all the powers of x and equate to 0 and solve for r. So from the general formula, if we just focus on the powers of x, we'll have x to the power of 12 minus r multiplied by 1 over x squared to the power of r will be equal to x to the power 0. So x to the power of 12 minus r multiplied by x to the power negative 2 to power r will be equal to x to the power 0. And if we just equate the powers of x, we'll have 12 minus r minus 2r is equals to 0. So 12 minus 3r is equals to 0, or 12 is equals to 3r, which means r is equals to 4. So the term in x to the power 0 can be now be written down. So the term in x to the power 0 is, so from the general term, we now have a specific term. So that will be 12 4 2x to the power of 12 minus 4 1 over x squared to power 4. And 12 choose 4 can be found from our calculators. So 12 choose 4 will be 495. So we have 495 multiplied by that will be 2 to the power 8, which is 256, x to the power 8 multiplied by 1 over x to the power 8. And again, you can see that the x to the power 8 will cancel. So our term in x to the power 0 will be equal to 126,720. Now, this is actually a fifth term. because r is equals to 4. In this example, we are required to find the constant term of 2 over z squared minus z to the power 15. So again, the constant term basically means the term in x in z to the power 0. So the term in z to the power 0. So what we need to do here is, because we are trying to find a specific term, we need to use the general term formula from the binomial theorem. So basically the first step is to write down the binomial theorem, which goes like this: a plus b to the power n is equals to whatever comes first plus the general term in that expansion, which is given by this formula, plus whatever comes next. So by inspection from the question, a is equal to 2 over z squared, b is equal to negative z, and n is equal to 15. So which means that the general term will be 15r, 15 choose r, and we just plug in what a is, which is 2 over z squared to the power 15 minus r, multiplied by b, which is negative z, to power r. So we need to find the term in z to power 0. Okay, so we need to find the term in z to power 0. So the combined powers of z is 0. So if the combined powers of z are 0, what we need to do here is to just focus on powers of z from the general term, and we equate them to 0. So focusing just on powers of z, we have 1 over z squared to power, so 1 over z squared to power 15 minus r, multiplied by negative z to power r, will be equal to z to power 0, because we want the term in z to power 0. So just by using laws of indices, this will be z to power negative 2 to power 15 minus r, multiplied by, in fact, we don't have to write negative z. We can just write z, because the negative does not have any effect, which is equals to z to power 0. So equating powers of z, we have negative 2 into 15 minus r, plus r is equals to 0. So which will be negative 30 plus 2r plus r is equals to 0. So 3r will be equal to 30 and r will be equal to 10. So given that r is 10, we can now write down the term in z to power 0. So the term in z to power 0 is 15 choose 10, and this is from the general term above, this general term here. So this will be 15 choose 0, 2 over z squared to power 15 minus 10, multiplied by negative z to power 10. And if we simplify this, 15 choose 10 can be found from our calculator. So 15, choose 10. That will be 3003. So we have 3003 multiplied by 2 over z squared, 2 power 5. So 2 over z squared, 2 power 5, multiplied by z to power 10. And this will be 3003 multiplied by 32 over z to power 10 multiplied by z to power 10. Now, obviously, these two cancel. So we just need to multiply these guys here, and that will be 96096. And this term here will be the 11th term because r is 10. Yeah? So this will be the 11th term because r is 10. That's not necessary, but you just need to know that that's the 11th term.